Let's have our lecture video in Engineering Economics with the topic Break-Even Analysis. Break-even analysis is performed to determine the value of a variable or parameter of a project or alternative that makes two elements equal. For example, the sales volume that will equate revenues and costs. A break-even study is performed for two alternatives to determine when either alternative is equally acceptable. Break-even analysis is a method of determining when costs equal or exactly equal to the revenue. Okay, so let's solve the examples in order to familiarize ourselves with the principle of break-even analysis. Number 1. General Electric Company, which manufacture electric motor, has a capacity of producing 150 motors a month. The variable costs are 4,000 pesos per month. The average selling price of the motor is 750 pesos per motor. Fixed costs of the company amount to 78,000 pesos per month, which includes all taxes. Determine the number of motors to be produced per month to break even and the sales volume in pesos at this point. How does the monthly production compare with the current break-even point? Okay, so having all these given, let's apply the definition of break-even analysis wherein it says there, it is when the costs equals the revenue. Okay, so let's have this cost equals revenue here. So cost equals the revenue. So let's calculate all the cost to make it consistent. Let's take it per month, since we can see here that the time frame is per month. Okay, so for the cost, we have here the variable cost is 4,000 pesos per month. So we have there 4,000. Then another cost is the fixed cost of 78,000 per month. So that's the only costs we have here. Then for the revenue, we have the revenue of 750 pesos per motor. Okay? So we have here for the cost, the 4,000 pesos per month plus the fixed cost of 78,000 per month. So this is the monthly costs that that this company is paying. Then the revenue is, we have the 750 pesos per motor. Then let's use the N value to represent the quantity produced. So we will put here N because we're looking for the quantity wherein the cost equals the revenue. Okay, so the value of N here is 109.33, or that is N is equal to 110 motors. So having this quantity of 110 motors, the cost equals revenue. Now let's show that in the graph. So let's have a graph here. Let's compare the, so this is in peso. So that is obviously the cost. And then we have here the number of units. The number of units, and that is in N. Now let's have the 750 pesos per motor. It means that if we plot it in the graph, the number of units compared with the cost it will grow upward. So the more units you produce, the more cost it will have. So the more money. Then we have, so this represents the revenue. Oh, let's not put it cost, it's just peso, the amount. Sorry, so it should be peso only, the amount. Okay, so revenue. This line here represents the revenue. The more units you produce, the greater the peso that you obtain. So the more N, the greater the peso. That's why we can see here a line that is going upward. Now for the costs, it says there per month. So every month we have there 4,000 and 78,000. So let's say that we have here the cost in blue. So that's the cost. So it is being fixed regardless of the number of units produced. That is the cost. Now take note that this is the break-even point. In this break-even point, we were able to compute here wherein the cost equals the revenue. We were able to compute that N is equal to 110 units. Wherein in 110 units, you will neither lose anything or profit anything, because this portion here actually is the loss, and this area here, this portion here, is the profit. Why? Because if you can see here, the cost is higher than the number of the amount or the revenue that you get. So that's why in this area it is the loss, and then at this point here it is the revenue. So meaning, if you increase the production here, if you increase the production of 110 units, if you go upward, then you will gain profit. But if the production is lower than the 110 units, therefore you will go to the loss. So having this idea, you will now determine on how many quantity of product you will produce in order to gain profit. As long as you know your costs, so you can compare. Or you can also adjust the revenue by adjusting the cost per motor, or the price of per motor. So you can play with the pricing using this data. Now the second question, or the second thing that we need to solve or to answer in this problem is, how does the monthly production compare with the current break-even point? So the current break-even point is 110 units. So the company is already producing 150 motors per month. So what does it mean? So the company is currently producing here 150 motors per month. So it means 150 is above the break-even value. Thus, there is profit. And we can compute the profit by subtracting the current monthly production minus the current break-even point multiplied with the price per motor, 750. So the profit is 30,000 pesos per month. So not bad. So indeed, the company is gaining or having a profit from the production of 150 motors a month given the cost per month. So that's for number 1. Next, let's go to number 2. A plywood manufacturer produces a piece of plywood at a labor cost of 50 cents and material at 3 pesos. The fixed charges on business are 50,000 a month and the variable cost is 50 cents a piece. If one plywood sells for 6 pesos each, how many pieces must be produced each month for the manufacturer to break even? So it is asking for the value of N, or the break even quantity. Okay, so again, let's have the cost equals revenue. But first, let's identify the costs. So it says there, and then we need to be consistent also. Okay, so a plywood manufacturer produces a piece of plywood. So there's a labor cost of 50 cents and 3 pesos per piece of plywood. So 0.50 and 3 pesos per piece of plywood. That is the cost. So let's put here 0.50 and then the number of pieces per month to break even plus 3 pesos number of pieces per month to break even. Next, we have it says their fixed charge of 50,000 a month. So it's still consistent because the N here is per month. Okay, so we have here plus 50,000 per month. Okay, so no more. No, there's still variable cost of 0.50 per piece. So another 0.50 N. So no more cost. So what's left is the revenue. So the revenue here is 6 pesos each. So we have there 6N. So what is the value for N, or the break-even value? So determine the number of item, or number of plywood to produce to break even. So that is 25,000 pieces. So having this data, the costs and the revenue, so it says there that you need to produce 25,000 pieces of plywood in order, this is the neutral point. So meaning, if you increase your production by say 26,000 pieces, then you are having now the profit. But if you produce less than 25,000 pieces, then you will incur loss. So this is the break-even point. Okay, next, let's go to the third example. A certain operation is now performed by hand. The labor cost per unit is 54 cents, and the annual fixed charge for tool use is estimated at 100 pesos per year. A machine that is being considered for this job will cost 2,400 pesos, having a salvage value of 100 pesos at any time and a fixed annual cost of 200 pesos. With it, labor cost is 22 cents per unit. For what number of units of product per year at zero interest and life of 6 years For the machine, will the annual cost of the two methods break even? So it's still in the definition of break even because we are determining the value of a variable or parameter of a project or alternative that makes two elements equal. Okay? So we are making them equal. Okay? So let's have the two alternatives. The first one is the hand operation or the manual operation. So the solution is first the manual operation. So the fixed charge is 100 pesos per year. The labor cost is, so labor cost is 0.54 per unit. So for the break even, let's put it N. Okay, so that's all for the manual operation. Let's go for the machine operation. So for the machine operation, we have the first cost of the machine as 2,400 pesos. Salvage value equals 100 pesos at any time. Fixed cost F of 200 pesos with the labor cost of 0.22 per unit. So let's put that N. Okay, so that's all for the cost. So 24, 100, 200, 0.22. Okay, now for the machine. So for the machine, it has first cost, salvage value, and the life of the machine is 6 years. How about percent? I is equal to, says there, 0 interest. Okay, so this is interesting. How do we deal with a 0 interest? So since we're dealing with the annual operation here, because of the presence of per year, so it says there annual operation, annual cost. So to be consistent, let's have all of them into annual work. So for the annual depreciation of the machine, let's compute it first. With 0 interest, so we have there the first cost of 2,400 minus the salvage value of 100 divided by the number of years. Since that is 0 interest, so it's just that we are dividing the amount by the number of years. There's no more interest involved. So that's why we are computing it this way. So that is 384.33 pesos for the annual depreciation cost. So finally, to break even, so we have here the hand or the manual operation. Manual operation equals the machine operation. So for the manual operation, we have 100 plus 0.54 N. Meaning the value of N that we will obtain here is the yearly quantity So versus what we have computed here, this is monthly production. So this is monthly because we are using monthly here. Here we have yearly production. Equals, for the machine operation, we have 384.33 plus we have 200 plus 0.22 n. So what's the value of n? So n is equal to 1513.53, or say that is 514 units. So that is being produced yearly. Let's go to the last example, number 4. A small aerospace company is evaluating two alternatives: the purchase of an automatic feed machine and a manual feed machine for a finishing process. The auto feed machine has an initial cost of $23,000, an estimated salvage value of $4,000, and a predicted life of 10 years. One person will operate the machine at a rate of $12 per hour. The expected output is 8 tons per hour. Annual maintenance and operating cost is expected to be $3,500. The alternative manual feed has a first cost of $8,000, no expected salvage value, a 5-year life, and an output of 6 tons per hour. However, 3 workers will be required at $8 per hour each. The machine will have an annual maintenance and operation cost of $1,500, and all projects are expected to generate a return of 10% per year. How many tons per year must be finished to justify the higher purchase cost of the auto feed machine? So how many tons per year must be finished to justify the higher purchase cost of the auto feed machine? So it's asking actually the number of n. First, we will compute the number of n for the break-even, so that it will mean that at that certain quantity that we get to produce, it will equal the cost, or it will equal the cost for the automatic and the manual machines. So if we get at that certain production, we can now justify buying the machine 1 or the automatic 1, which we will expect to be more costly. But having that number of productions, it will justify the cost. So that's what it means here. So just as what happened here, comparing two alternatives, the manual and the machine, meaning if we produce 1,500 units, 1,514 units here, it means you can now have the machine operation, or anyone here that is more costlier, it can justify because this is the number of units that will justify your having those two options. So if having 1,514 units will garner profit from the two alternatives, then why not? You can consider buying the costlier one. Okay, so for number 4, let's solve this. Again, let's make it consistent. Are we going to solve it monthly or are we solving it as yearly? Okay, so let's check. So the life of the machine is 10 years. And the output here is 8 tons per hour. But the percentage is 10% per year. Says their annual maintenance. So I'm not looking I'm not seeing any monthly here, so let's just go for the yearly, and then let's be consistent in using the yearly or the annual word. Okay, so let's start with the first one. The first alternative is the auto feed. The auto feed machine. Now for the auto feed machine, which has the initial cost of $23,000 and the estimated salvage value of $4,000. Now if you imagine this in a cash flow diagram, so downward for the cost, so that is 23,000, the first cost, and then you have the salvage value upward because it is a revenue, so a positive inflow of cash, so $4,000. Oh, it should be in dollars, sorry. So what will happen here is that we will compute them both into annual worth. So we have the formula for annual worth if the given is the present cost. So the present cost is 23,000 equals the annual worth. Then we have 1 plus the percent here is 10%. So 0.1. Then the life of the machine is, predicted life is 10 years. So raised to 10 minus 1 all over 1 plus 0.1 raised to 10, 0.1. So annual worth here is equal to $3,743.14. The other one, the 4,000 salvage value. So 4,000 is a future worth. Let's compute the annuity. So 1 plus 0.1 raised to 10 minus 1. And then the denominator here for future worth is 0.1. So annual worth is $250.98. Okay, so we're done with the first cost and the salvage value. What's next is the labor cost, that is $12 per hour. So for the $12 per hour, let's compute for the labor cost. Okay, so LC, labor cost, that is $12 per hour. Convert that into yearly because we have here 1 hour per 8 tons. The expected output is 8 tons per hour. So let's have it as okay, so for us to get an amount, so this is the expected output. So they will have the 8 tons per hour. So we have here 1 hour, 48 tons. Okay, and then we have here the N tons per year, because we're actually computing for the number of so in the question, how many tons per year must be finished to justify the higher purchase cost. So we have here, we need to multiply it with N tons per year, N being the asked. So LC now is equal to 1.5 N. Okay, so I think we're done with the 8 tons per hour. How about the annual operating cost? Let's just put it in the computation. So for annual worth of auto feed machine, so AWA, let's put that into AWA, equals, we have the 3743 as, let's use negative sign. Okay, let's have here, note, use negative sign for costs, for consistency. Okay, so negative 3,743.14 plus, so we will add the 250.98 because that is inflow of cash, minus the annual operating cost of 3.5 minus the labor cost of 1.5 N. Okay, so what is now AWA or AW sub A? Annual worth of auto feed. Okay, so that is negative 6992.16 minus 1.5 N. Okay. So we have now the auto feed machine. Let's go to the manual feed. Okay, for the manual feed, what we have here, the first cost of the machine is $8,000 and the expected salvage value, there is no salvage value. So let's just compute the annual cost of $8,000. So that is 8,000 equals annuity times 1 plus 0.1 raised to how many years? Expected lifespan, that is 5 raised to 5. It should be raised to 5 minus 1 all over 1 plus 0.1 raised to 5 times 0.1. So A is now equal to 2110.38. Okay, next. So we have here the annual maintenance cost is 1.5. So let's just add it later on. So we have labor cost. 3 workers. It says there 3 workers will be required at $8 per hour each. Expected output 6 tons per hour. So just as we did a while ago, so we have here labor cost equals, that is $8 per hour. Then we have there 3 times 3 operators. Let's multiply it with 3. Then we have 1 hour in 6 tons. Is that right? Per hour. 6 tons per hour. 6 tons, and then we're looking for the N tons per year, so that we will cancel out hour and cancel out tons. So labor cost becomes 4 times N. Okay? So now we have here the annual worth of the manual feed, AW sub M. That is equal to negative 2110.38 minus 1,500 for the annual operation cost minus 4N. So AW sub M is negative 3,610.38 minus 4N. Okay, let's equate AW annual equals AW manual for the break-even point. So for AW automatic, should I say, AW automatic, negative 6,992.16 minus 1.5N equals negative 3,610.38 minus 4N. So cancel out all negative signs because they're all negative. So N is equal to 1,353, because it's 1,352.71, say 1,353 tons per year. So that's the break-even point. So that's the amount wherein if you exceed that 1,353 tons, then there will be profit. And this actually justifies the purchase of the automatic feed machine, because you will profit at 1,353 tons per year. So that's the last problem for this video.